Hello there. Today we'll be doing find medians of two sorted arrays. This is a very interesting problem. What we're going to do here is find a median in a list of numbers. In this list of numbers, 1, 2, 3, 4, 5, the median number is 3. If you have two numbers, we're going to take the average between the lesser and the greater number. Yes, in the middle. And that's going to be our median number. So the thing is about this problem, we have to do this in O of log m plus m time, which is a binary. Because even if these are separated, we can just do 2 pointers, one from the left and one from the right, and just move in to the number that is in the middle by finding out which one's greater. Well, we'll have one, I guess. Yeah. We'll go back. We'll go from one side. Sorry. So we'll go from one side, and we'll just move. Oh, this one's bigger. This one's smaller. So move it forward. This one like L1 and L2. So and this one's lesser. So we keep moving it forward until look. This is out of bounds, and so that means that the median is right here, and the median is this first one right here. And that's one way to do it, but that's going to take us O of m time, or yes, half the distance. But what we're trying to do is log. So how we're going to get log? Well, the way to do it is we're going to we know that we need half the items. So we're going to take a left and right pointer on this side, right? And what we're going to do is we know that we need a total of three numbers. If we had, to make this easier for us, let's use 10 numbers. I like 10. Easy to think about, easier to understand. So So right here is left and right, and we need half the numbers. So let's say we have a median right here, the middle, and we're gonna get let's say 3 numbers from here. That means we're gonna get 2 numbers from here, from this other side. Yes, from this other side. Let me just move it down so it's easier for us to talk about. So we're going to get these 2 numbers here. So that's the median right here, because our total number is 5 out of 10. And the same thing if we had odd numbers, we want in the 5 numbers. So with that, we have so with that, we see that we try to attach the 3 with the 6 in front of it, and the 7 before the 4, and that's not right. We have to make sure that all the numbers to the right is greater than all the numbers to the left. So that means that it's too much. We have that number is too high. So we need more numbers. So you need to move the left up to m plus 1. So now we have m plus 1, 4, 9, 5, 4. So median is now at 4. And so we take 4 numbers, and that means we need to take 1 number on this side. Now that we have 1 number, what we're gonna do here is see if this number, this on the left side, this left number is anything greater than this number, right? This median number, plus 1, and this number has to be greater than this number, but that's not the case. So we keep moving because we need to make sure all the numbers to the right is less than all the numbers to the left. And the only way to do that is to make sure that the median number on the number 1 is greater than everything on the median number on the right, number 2. And the same for median number on number 2 array is greater than everything on the median of the number 1 array. So now we're here, and we move the left up, and we're 5. We take 5 numbers. That means we take a 0 numbers here. That means once we take 0 numbers, then we're done here, and we'll take all 5 numbers, and the median is at 5. And then we take basically the minimum, the maximum of this number and the maximum of this number, and we get these two numbers here, and we add them up and divide by 2, and we have 5.5. And that's how we do this problem. So let's get to it. If you think this is unclear, I will work harder to make this more clear. So let's do it. So first things first, n1 and n2 is equal to the length of nums1 and nums2. So if nums1 is greater than nums2, we're gonna return self.find medium sorted arrays and swap the two, because we need to make sure that we're getting all the items from the half. So nums2 is always going to be the bigger one for us, and nums1 will be the one where we chip away at it. So left and right is equal to 0 and n1. The reason why we use n1 is because we want to make sure that we count for being out of bounds, and the half is equal to n1 plus n2 plus 1 divided by 2, because we want to get the middle number, the half number, whether we're looking at a odd and an even. So if we had 9 items, so plus 1, we would get 5. If we had 10, we would look at 11, and we would also get 5. All right. So with that, we're going to look at the next thing. So while left is less than or equal to right, the mid 1 is equal to left plus right divided by 2. This same old for all binary search. Mid 2 is equal to the half minus the mid of 1. So basically, the numbers that we take or not take, whether it's 0 or all the way, take all the numbers, which is one greater than this, which is 5. Then yeah, we're gonna take all the numbers. Okay, so left 1 and is gonna be our left number here. It's gonna be our mid 1, basically, because we need 2 numbers, the one greater than our mid. So I think actually, so mid 1 num oh, mid 1 num is equal to the float of negative int if mid 1 is equal to 0. That means we have no numbers that we want. Else we're going to take the nums of mid 1 minus 1. Mid 2 num is equal to the float of a negative infinite. That means we're not taking any numbers. If mid 2 equals 0, else nums 2, mid 2 minus 1. Now mid 1 num plus is equal to, that means it's 1 greater than the mid 1 nums, is going to be so the index is going to be 1 greater. So if basically we're going to not take, we're going to take, I guess, everything from this side. Mid 1 is equal to n1 nums of 1. That means this is out of bounds at this point. So mid 1 and mid 2 num plus is equal to float of inf if mid 2 is equal to nums 2 nums mid 2. All right, with that, we can make sure that mid 1 num is less than or equal to mid2 num plus, and mid2 num is less than or equal to mid1 num plus. And that way, if that way we know that all the numbers on the right is greater than all the numbers on the left, and we can return whether, depending on whether it's even or odd. I think it's clearer if we do this, equals 0. I mean, we could just say divided by 0 is 0 and it just makes sense of it, but I think this reads more clearly, and so I'm going to do this. So if it's basically even, then we're going to take the max of mid1 nums and mid2 num plus the min of the right number of so that we get the two middle numbers, mid1 num plus and mid2 num plus divided by 2. Otherwise, we're going to return the max between the two mid ones to get the correct number, the one that's in front. Okay. Anyways, so else if the mid1 num that is greater than mid2 num plus, that means that the number on the top array is greater than the number on the bottom. That means we have too few numbers on the bottom array here, and we need more on top. So we need more numbers. So what does that mean? That means that we're going to move the left up, so we get more numbers. Or are we going to move the right down to get more numbers? No, we need to remove right down because we have way too many numbers up here. Because, let's see, let me explain. So we have left and right. So if our mid is in the middle, right, if we have too many numbers, that means if we move the right down, we can get fewer numbers. We need to move right down. Otherwise, mid2 num is greater than mid1 num plus. So that means that we have way too many numbers in here, and we have way too few numbers up here, so we need to move the left up so that we can get more numbers. And with that, we have the right number of between the two, and we can submit our answer. Oh look, an error. That's not a problem. Let's check it out. There's no else statement for some reason. Let's see what's going on here. Nums2 and what's going on here is that I'm just making typos everywhere right now. Hopefully that's the end of it. Oh yeah, there's more where that came from. I guess this is a very difficult problem, and because it's so difficult for me, that there are a lot of typos that I'm making. Let's see, num1 plus num. I'm making so many typos. The easier way to make sure that there are few typos is to make the names easier to type, but then it makes looking for errors even harder. So like just now we have an error, and it looks like the problem is that the bottom is a greater and the top is lesser, but then it's still causing a problem, and I'm not exactly sure why. Let's see. So I think Everything is looking good here. I'm not sure exactly what's the problem. Well, why it's not picking that up. Why would it return infinite? Hmm. I don't see any problems actually. Oh, I see. Oh, I see. That's the problem right here. This is getting the max of um the mid number, and this is getting the max of the right number. Um let me see if I understand what's going on. I don't see anything. I really don't see it. I wish I could tell you. Um, that's the problem. That is the craziest typo I have ever seen in my life. Um, great. Well, sorry about that typos. A lot of typos here. I'm. This is a pretty complex and intricate problem, and there's bound to be a lot of typos. Hopefully, next time around, when I get to this problem again, there will be fewer typos, and this will be a lot clearer next time. But as you can see, um, we had a pretty good answer here, and it's pretty good. And I think we thoroughly explained about way most of the code, and we talked about it. And so I think this is okay, and hopefully the next iteration will be even better. Thank you very much, and I hope you have a good one. Please comment below if you think we need another video about this. Thank you. All right, enjoy the rest of the day. Like and subscribe. Bye.